Something remarkable is unfolding around Comet 3 I Atlas. And over the last few weeks, the story has escalated faster than almost anyone expected. NASA had been silent for months, but that silence finally broke. They confirmed that they would release high-resolution images of the object, taken during its close approach to Mars on October 3rd, and they scheduled a live stream for November 19th at noon Pacific time. That announcement alone sent shockwaves across the astronomy community. NASA rarely hosts a dedicated event for a comet. It only happens when the data is compelling, extraordinary even. And when that live stream page quietly went up, it immediately fueled speculation about why now and why this object. Around the same time, new images of 3I Atlas started circulating online, drawing intense attention from astronomers and amateurs alike. These weren't blurry streaks or vague smears. They were sharp, high-contrast frames showing a bright cloud with structure. Real, layered, organized structure. The colors were unusual. The shape shifted slightly from frame to frame, and the tail didn't behave like the tail of a normal comet. It looked asymmetrical, almost unstable, as if something inside the cloud were twisting or pushing it off balance. From that moment on, the story began to snowball. More and more observers started pointing their telescopes at 3I Atlas, and the strange details kept piling up. The comet's brightness fluctuated rapidly. The jets shooting from its surface didn't behave like natural outgassing, and the tail seemed to shift directions in a way that didn't match expectations. Normally, a comet's tail is shaped almost entirely by the solar wind. It should point away from the sun in a predictable way, but this one seemed to bend, twist, and even sharpen into thin, beam-like structures. Then the independent astronomers stepped in. Without waiting for NASA or any official agency, they uploaded real-time observations night after night. These weren't polished scientific papers. They were raw, unfiltered images. And yet they revealed details that were impossible to ignore. In some sequences, the comet's outline changed noticeably in less than 10 minutes. For a natural comet nucleus, normally rotating over many hours, this kind of rapid evolution was unheard of. This is when the debates began. Some researchers proposed that the comet had extremely asymmetric jets that could act like natural thrusters, spinning the nucleus faster than normal. Others suggested it might be tumbling chaotically due to uneven heating. Both of those are scientifically plausible, but neither fully explains why the comet's shape seemed to reorganize itself so quickly, or so consistently, across multiple observations. A particularly talked-about set of images came from an amateur using nothing more than a standard telescope and an RGB camera with the IR/UV filter removed. He stacked dozens of exposures to reduce noise, sharpened the image gently, and captured a sequence where 3I/ATLAS appeared to twist, stretch, and flare in a rhythmic pattern. Jets shot outward like blades of light. Brightness shifted across the coma almost like pulses. To him, the conclusion was obvious. The comet was rotating extremely fast. Whether that rotation is natural or not is still up for debate. Around the same time, Avi Loeb published a collection of high-clarity images that pushed the intrigue even further. These images showed a network of bright filaments, crisscrossing jets, and branching structures that looked more mechanical than chaotic. The reverse tail pointing toward the sun, something incredibly rare, stood out as the most bizarre feature of all. In normal physics, the solar wind blasts material away from the sun. A sunward tail requires a very unusual explanation, either extremely heavy dust particles or a complex geometry that fools our perspective. But even those explanations struggle to account for the sharpness and consistency seen across multiple days. Then there's the narrow, collimated plume extending far into space, a structure so clean, so thin, and so coherent that many observers compared it to a beam more than a tail. This plume didn't appear once and vanish. It recurred across several nights of observations, maintaining its directional structure with surprising stability. All of this made the public wonder, is this just a comet behaving strangely, or are we witnessing something fundamentally different? Meanwhile, SETI kept quiet about the comet's rotation, tail anomalies, or unusual jet patterns. They stuck to their usual cautious approach and avoided speculation. But their decision to direct the public toward NASA's upcoming announcement felt meaningful. They don't promote ordinary events. When they highlight something, it usually means the data contains something genuinely unexpected. NASA's livestream confirmed that multiple spacecraft and telescopes had observed 3I Atlas from different angles and wavelengths. That means NASA holds far more precise data than what ground observers captured through the atmosphere. If the comet really is spinning unusually fast, NASA will have the evidence. If the jets sweep in arcs or follow organized paths, spacecraft imaging will reveal it. And if the sunward reverse tail is real and not an optical illusion, NASA's multispectral analysis will be able to explain what forces shaped it. Right now, the world is looking at 3I/ATLAS through the limitations of Earth-based telescopes, weather, turbulence, and angle. But soon, we'll see it through the eyes of spacecraft far above those distortions. And that's why the upcoming NASA release matters so much. It could confirm the independent observations, contradict them entirely, or reveal a more complex picture than anyone expected. Scientifically plausible explanations still exist. Rapid rotation from asymmetric jets is possible. Tumbling due to thermal stress is possible. Interstellar ice mixtures behaving strangely under sunlight is possible. None of these ideas require anything extraordinary, just conditions we've never seen before. But the visual evidence continues to raise questions. Multiple jets firing in coordinated directions, a reverse tail that shouldn't exist under normal solar wind conditions, a narrow, beam-like plume that stays stable across days. Patterns that look intentional, even if the underlying cause is natural. NASA's cautious silence, SETI's controlled interest, and the independent community's explosive findings have created a rare moment in astronomy. One where the scientific world, the public, and the media are all waiting for the same answer. As the countdown to November 19th approaches, observers continue capturing new frames each night. And with each image, the same question becomes harder to ignore. Is 3I Atlas simply a comet with extreme, unfamiliar physics? Or is it an interstellar visitor behaving in ways we've never seen before? Whatever NASA reveals, it's clear that this comet is not just another dusty wanderer from deep space. It has already forced scientists to re-examine long-held assumptions about comet dynamics, interstellar chemistry, and how objects behave when they travel between the stars. The real mystery isn't whether 3I/ATLAS is unusual. The real mystery is why. And with NASA's data only moments away, we're about to find out just how far this rabbit hole goes.